Number 6, part B, it says the graph of sine repeats itself every 90 degrees. Is that true? Because the graph of sine repeats itself every 90 degrees. So let's go to unit 5D to verify whether or not. Or we can use Symbolab and sketch a graph of, number of sine, okay? But we can just go to unit 5D. Let us see if we get a sine graph somewhere. Sine of any angle. Here's the sine. Here's a sine graph. So as you can see, this sine graph, it starts with sine of 0 is 0, and we know why sine of 0 is 0. Sine of 0 is 0 because at 0 degrees, okay, the opposite is 0. Okay, at 0 degrees, the opposite is 0, because bear in mind, sine depends on opposite to the angle. So at 0 degrees, you only have adjacent and hypotenuse. So sine of 0 is 0. All right. Sine of 90 is 1 because the opposite and the hypotenuse is equal in length. And sine of 180 degrees is 0. Sine of 270 is -1 because the opposite is on the negative side, value of 1, or value equal to the hypotenuse. Sine of 360 degrees is 0. And this cycle repeats itself after 360. Okay. So this pattern does not repeat after 90 degrees. No. Okay. It says the graph of sine, the entire graph of sine repeats itself every 90 degrees. No. Okay, because at 90 degrees, new things are happening. After 90 degrees, things that did not happen before 90 degrees is now happening. Look, 90 degrees there, you know, that's the maximum value of sine, you see, rotating 90 degrees. Look, new things are happening. The graph is decreasing. So that's not a repetition of that upward motion. Okay. After 180 degrees, new things are still happening. Okay. And after 270, new things are happening again. This cycle will repeat again after 360 degrees. So therefore, this statement is false. The capital F. The sine graph repeats after 360 degrees. Okay. Not after 90 degrees. Okay. If you want, you can even put the correction in brackets, italics is in the first and second quadrant. That is where sine is positive. Bracket in italics, every 360 degrees. That is when the sine graph repeats.